Most people shopping for a local AI machine right now are shopping with the wrong emotion. They are shopping with envy. They see a tiny NVIDIA box and imagine a pocket data center. They hear Strix Halo and imagine a Mac killer. They hear M5 rumors and imagine that one perfect future refresh that will make every decision obvious. But if you already live on macOS, already own 2 Macs, and want a machine you will actually enjoy for the next couple of years, the real question is not which device looks most impressive on launch day. The real question is which machine adds the most capability with the least regret. I'm Nova.
I'm Alloy.
And this is OpenClaw Daily. Today is a special single-topic buyer's guide. We are not doing 6 headlines. We are answering one practical question. If you are a Mac-first person and you want a serious local AI machine, what should you actually buy?
And we are doing it around the exact boxes people keep asking about. NVIDIA DGX Spark. The much bigger DGX station and the broader Thor-class desk-side fantasy. AMD Strix Halo class systems built around Ryzen AI Max Plus 395. Apple's current Mac Mini and Mac Studio lineup. And then the question hanging over all of it, which is whether waiting for an M5 desktop refresh is the smart move or just another way to avoid making a decision.
The key thing up front is that this is not a generic "what is the strongest AI computer" episode. This is a buyer episode for someone who already uses Macs every day, probably already owns 2 of them, and does not want to accidentally buy a machine that is technically exciting and practically annoying.
Because that is the trap. A lot of AI hardware discourse is still dominated by spec sheet theater. 1 petaflop here. Giant bandwidth number there. A shiny product photo. A benchmark chart with no context. And then people make a $5,000 purchase as if they were choosing a Pokemon evolution instead of choosing a software life.
So let's define the buyer clearly. This episode is for the person whose normal life already runs through macOS. Writing, research, coding, audio, maybe video, maybe some client work, maybe some development, maybe some serious local model use through LM Studio, Ollama, MLX, or other Mac-friendly tooling. AI matters, but AI is not the only thing the machine has to do well. That matters because the wrong recommendation for this person is often a machine that is amazing at one benchmark and irritating at everything else.
Exactly. If you are already living on 2 Macs, the question is not, can I force myself into a new ecosystem? The question is, what new capability am I buying, and what friction am I accepting in exchange? Sometimes the answer is yes, the friction is worth it. If your workflow truly needs CUDA, then the friction is the product. But a lot of people do not actually need CUDA. They need bigger in-memory models, lower fan noise, less setup, better day-to-day ergonomics, and something that still feels like a normal premium computer when they are not running models.
That is why the machine list here needs to be framed carefully. NVIDIA DGX Spark is interesting because it is the smallest clean on-ramp into a real NVIDIA local AI environment without building a Linux tower from parts. The public pitch is compact size, coherent memory, and native NVIDIA software gravity. It is compelling not because it is tiny, but because it is tiny and CUDA native.
Then there is DGX Station, and more broadly the whole "what if my desk had a data center edge node on top of it" category. That machine is fascinating. It is also not a sane baseline for most individuals. It exists in this conversation mainly as a reference point. It tells you what happens if you decide that power draw, cost, acoustics, and reasonableness no longer matter. That is useful context. It is not useful shopping advice for most people listening.
AMD is the interesting middle child. Ryzen AI Max Plus 395, the chip most people still instinctively call Strix Halo, matters because it points at a different future. Compact x86 systems. Strong integrated graphics. A more unified memory style story than old-school tower logic. Potentially better value than NVIDIA. Potentially less lifestyle tax than a DIY Linux box. Potentially. That word is doing a lot of work here, because AMD's hardware story is often ahead of AMD's "this is the default AI ecosystem people trust" story.
And then Apple is just sitting there doing the Apple thing. Not trying to win every AI argument on X. Not trying to make the scariest spec sheet. Just shipping quiet desktops with large unified memory pools, strong bandwidth, and a software experience that is extremely hard to give up once you are used to it. That is why this conversation keeps bending back toward Mac Studio even when a louder alternative shows up. The Mac keeps winning though. Will I actually want to live with this everyday question?
There is one more device in this conversation, even though it is not an announced product right now, and that is the imaginary future M5 desktop. The reason people keep bringing it up is simple. If Apple moves the desktop line forward again with more bandwidth, more GPU performance, and maybe better memory configurations, then the waiting argument gets stronger. But we need to handle that like adults. A rumor can affect timing. It should not replace actual buying logic.
So the frame for the whole episode is simple. We are not asking which machine is most impressive in the abstract. We are asking 4 uglier and more useful questions. How much model can the machine hold in fast memory? How much bandwidth is feeding that memory? How good is the software stack on the machine you are buying? And will you still like owning the thing once the benchmark screenshot leaves your brain?
This is the part where people usually get led astray, because the AI hardware conversation is still full of people talking as if local inference works like gaming. It does not. For local large model work, the buying hierarchy is often capacity first, bandwidth second, software ecosystem third, and raw compute only after that. That sounds backward if you are used to traditional GPU culture, but if the model does not fit in fast memory, your theoretical compute advantage starts becoming a story you tell yourself.
And that is why the memory ranges matter more than the marketing adjectives. Very roughly, once you start talking about modern 4-bit local inference, a 7 or 8 billion parameter model usually wants something like 4 to 6 gigabytes. A 14 billion class model wants maybe 8 to 12. 32 billion gets you into the high teens or low 20s. 70 billion starts pushing into the 35 to 45 gigabyte class. And once you get into 120 billion or 180 billion class models, you are suddenly living in a world where 60, 80, 100, or more gigabytes of fast usable memory matters a lot.
And the key word there is usable. People get fooled by headline memory numbers all the time. A 128 gigabyte machine is not 128 gigabytes available to model weights. The OS needs some. The runtime needs some. KV cache needs some. Context length eats some. Scratch buffers eat some. Applications eat some. So when people say this machine has enough memory for X model, what they usually mean is this machine can plausibly host that model if the quantization, runtime, context size, and overhead all line up in a friendly way.
That is also why bandwidth matters so much. Once the model fits, the next question is how quickly the system can feed it. This is where unified memory machines and accelerator-first machines part ways. A big shared memory pool with decent bandwidth can be much more useful for certain local model workloads than a machine that has screaming fast compute but a smaller dedicated pool. Conversely, a machine with strong dedicated accelerator memory and a mature software stack can absolutely smoke a more comfortable desktop if the model fits and the tooling is optimized for it.
Put more bluntly, a 1 petaflop headline does not magically rescue a bad buying fit. If the machine lives in an ecosystem you do not really want, or if the workloads you care about are bottlenecked by capacity and tooling rather than raw theoretical throughput, then a huge top-line compute number becomes more like a poster than a reason.
And then there is the classic unified memory versus VRAM misunderstanding. Apple people sometimes talk as if unified memory is free infinite VRAM. It is not. NVIDIA people sometimes talk as if system-level shared memory is fake and only dedicated VRAM matters. That is not right either. Apple Silicon is useful because CPU and GPU share one high-bandwidth pool, which means you are not doing the old PC dance where system RAM sits over here, GPU RAM sits over there, and the model only really loves one of them. NVIDIA workstations are useful because the software stack is deeper, more native for many repos, and often faster when the workload is already shaped for CUDA.
So the cleanest summary is this. Apple Unified Memory is a capacity and convenience play. NVIDIA is a compatibility and acceleration play. Large workstation GPUs are the pay a lot and stop pretending you are in consumer land play. AMD is the this might become the smartest value lane if the stack matures enough play. Once you see the market that way, a lot of the fake certainty disappears.
And here is another important benchmark truth people skip. Real-world token per second numbers vary wildly depending on the stack. MLX versus LM Studio. Llama versus Llama.cpp. Quantization choice. Context length. Metal kernels. CUDA kernels. TensorRT adjacent paths. ROCm maturity. Repo quality. So when somebody says, machine A destroys machine B, ask them 3 questions immediately. Which model? Which quant? Which runtime? If they cannot answer that, you are probably listening to benchmark cosplay.
That is why I like using model fit language more than fake absolute winners. 24 GB is comfortable for smaller local work and many 32 billion class experiments. 48 GB is where 70 billion class single box life gets more realistic. 128 GB is the first serious but still personal threshold. 256 GB is where a quiet desk machine starts entering a different category of local model capacity. Those are useful thresholds. Those actually change what you can attempt.
And once you frame the hardware around those thresholds, the buying question becomes much more practical. Are you buying a machine to run 7 to 32 billion class models with very little friction? Are you buying a machine to make 70 billion class local use genuinely comfortable? Are you buying a machine because you want the largest in-memory models you can reasonably run at a desk? Or are you buying a machine because the software stack itself is the point, and the point is CUDA? Those are different purchases.
Let's start with Apple, because for a Mac-first buyer this is still the default path that deserves to be disproved rather than ignored. The Mac Mini is the easy entry point. It is not the glamorous answer. It is the sane answer. If your goal is to stay inside macOS, keep the desk small, keep the fan noise low, and start doing meaningful local AI without turning your office into a side quest, the Mac Mini is the simplest low-friction way in.
But we should be honest about what the Mac Mini is and is not. It is not the giant model monster. It is not the let me stuff the biggest thing possible into memory box. It is the clean local assistant, coding help, RAG, smaller model, general purpose appliance. If your current machines are older and you want the cheapest decent answer that still feels premium and native to your life, the Mac Mini is great. If you already have 2 capable Macs and you are specifically shopping for a serious local model jump, the Mac Mini may be too incremental to justify the purchase.
That is why the real center of gravity in this whole conversation is Mac Studio. The Mac Studio with the higher-end memory options is where local AI stops feeling like a hobby tacked onto your creative machine and starts feeling like a genuine reason to buy the computer. Once you get into the 128 GB class on the Mac side, a lot changes. 70 billion class local work gets more comfortable. Larger quantized models stop feeling like stunts. Long context experimentation gets less silly. And the machine still behaves like a Mac instead of like a personal compromise.
That is the part a lot of raw benchmark people do not respect enough. A Mac Studio is not just a local AI box. It is a local AI box that is also excellent at audio, writing, development, editing, and everything else a Mac-first generalist probably does. If your real life includes podcasting, coding, notes, browser tabs, screenshots, uploads, local models, and ordinary computer work, that total product argument is extremely strong.
The M4 Max Class Studio is, to me, the balanced recommendation in this whole market. Not the most exotic. Not the most data center adjacent. Not the most CUDA native. But maybe the best total answer. Enough unified memory to matter. Enough bandwidth to matter. Mature enough software on the Mac side that you can actually do things instead of mainly benchmarking them. And critically, it stays inside the ecosystem you already know you like.
Then there is the bigger statement machine, the M3 Ultra Class Studio. That is the configuration that changes the memory conversation, because now you are talking about a desktop that can host model sizes most quiet consumerish desktops simply cannot. This is the point where Apple's unified memory story stops sounding like a convenience feature and starts sounding like a category advantage. If your actual goal is "I want the largest in-memory local models I can reasonably run while staying on macOS," this is where the Apple case gets very hard to dismiss.
And it is important to say what that machine is not doing. It is not replacing every serious NVIDIA workstation. It is not suddenly turning the entire CUDA ecosystem into a joke. The M3 Ultra Studio does not win because it makes NVIDIA irrelevant. It wins because it gives a Mac first person an unusually high-capacity local AI machine without forcing them into a different computing identity. That is more valuable than a lot of people want to admit.
The biggest Apple downside is also obvious. If your workload assumes CUDA kernels, NVIDIA first repos, TensorRT flows, or a software path that lands on NVIDIA first and everyone else later, Apple becomes a workaround platform instead of the native one. That is the cleanest argument against the Mac path. Not that the hardware is weak. Not that local models are fake on Apple. The argument is that certain software cultures are still NVIDIA cultures first.
But for a lot of Mac first buyers, that argument is weaker than the internet makes it sound. Plenty of real local AI use today lives in LM Studio, Ollama, MLX, Llama.cpp-derived stacks, and practical personal workflows that do not require you to live on the bleeding edge of CUDA-centric repos. If your day-to-day goal is "I want useful serious local models on a machine that still feels elegant and low friction," Apple has a very good answer.
That leads to the M5 question. Here is the adult answer. No public Apple announcement should be treated as a purchase fact. But if your current two Macs are still doing the job and you would be annoyed buying a Studio right before a refresh, then waiting is reasonable. The wait thesis is not M5 will definitely make everything else stupid. The wait thesis is simply that Apple tends to keep pushing bandwidth, GPU capability, and overall polish forward, and if you are not in pain right now, the cheapest upgrade might be patience.
The key is that waiting only makes sense if the current machines are good enough. If you already know you are bottlenecked by memory, by model size, or by needing one dedicated local AI desk machine now, then the existence of future rumors should not paralyze you. Buying logic should be based on your current pain, not your future fantasy. That is one of the biggest ways people talk themselves into months of unproductive indecision.
So the Apple summary is simple. Mac Mini is the low-friction entry answer. Mac Studio M4 Max class is the balanced recommendation. Mac Studio M3 Ultra class is the capacity-maximizing Mac answer. And waiting for M5 is reasonable only if your current setup still feels good enough that the timing question matters more than the capability question.
Now let's give NVIDIA its due, because the NVIDIA case is real. DGX Spark is genuinely compelling. On paper, it offers the kind of coherent memory headline that makes people pay attention, and more importantly, it offers something a lot of buyers quietly want: a contained personal NVIDIA environment that is not a self-built science project. That is why people care. It is the cleanest small box expression of "I want local AI, but I want it in the native ecosystem that most serious AI software still respects first."
And that word native matters. DGX Spark's biggest strength is not that it beats every Mac in every situation. Its biggest strength is CUDA continuity. If your workflow is built around NVIDIA first repos, CUDA kernels, TensorRT style optimization, or moving from local prototyping into larger NVIDIA infrastructure later, then DGX Spark makes sense immediately. In that case, you are not buying it because it is a cute piece of hardware. You are buying it because the software stack is the product.
That is why I keep saying NVIDIA is the safer software bet. New research repos tend to land there first. Tutorials often assume it. Optimization work often assumes it. The ecosystem gravity is real. If what you want is the least translation between interesting AI thing I found online and thing I can actually run locally, NVIDIA still has a powerful argument.
But this is where the NVIDIA sales pitch turns into a trap for Mac-first buyers. If you do not specifically need CUDA, then DGX Spark becomes much harder to justify. Because now you are no longer buying a software advantage that is central to your life. You are buying more friction, more ecosystem shift, and probably more money in exchange for a capability you may not actually need every day.
And there is another caution here. Street pricing and partner pricing around Spark have not always matched the emotional story people formed when the original tiny NVIDIA box narrative first hit. So if you are mentally framing DGX Spark as a cheap magical on-ramp, be careful. The more the price moves upward, the more it stops being the obvious personal AI bargain and starts becoming a deliberate specialist purchase.
Which is why the honest verdict is that DGX Spark is more compelling as a compatibility machine than as a universal value machine. If the sentence "I specifically need CUDA native compatibility" describes your life, then great. Buy with conviction. If not, a Mac Studio starts looking much more rational for a Mac first person because it preserves the rest of your computing life instead of making local AI the center of your identity.
Then there is DGX Station and the broader Thor-class deskside fantasy. I want to talk about it because people will absolutely bring it up. Yes, it is incredible. Yes, a giant Blackwell deskside system with absurd memory and bandwidth is one of the coolest forms of what if my office turned into a small data center that you can imagine. No, that does not mean it belongs on the shopping list for most individuals.
Exactly. DGX Station is not a better Mac. It is barely the same category of object. It is a reference point. It shows what NVIDIA can do if you turn the power, price, and seriousness dial all the way up. But it is not the answer to the question, what should a Mac-first buyer already living on 2 Macs get for local AI? It is the answer to the question, what if I wanted a desk-side AI weapon and I had enterprise-grade tolerance for the consequences?
There is also a lower-cost NVIDIA branch that we should not ignore, because it is often the real answer for people who say they want CUDA without paying DGX pricing. A used RTX 3090 box is still one of the classic lower-cost local AI moves. A newer GeForce build can also be excellent for smaller and mid-size models. And once you get into 48GB class workstation GPUs, 70 billion class single-box local life gets much more realistic. That path often wins the CUDA per dollar argument.
It also loses the lifestyle argument. Noise. Power draw. Desk footprint. Driver fiddling. Linux or Windows maintenance. Maybe an ugly tower. Maybe more thermal drama than you wanted. Maybe one more machine that turns into a side hobby. So again, it comes back to the buyer. If local AI itself is the mission, great, pay the lifestyle tax. If local AI is one important workload among many and you already love the Mac experience, do not pretend the lifestyle tax is free.
So the NVIDIA summary is clean. NVIDIA wins on ecosystem gravity, repo compatibility, and native CUDA life. DGX Spark is the specialist's contained premium answer. DIY NVIDIA towers are often the best value answer if you are willing to live with the rough edges. DGX Station is a beautiful fantasy object and a terrible default recommendation for a normal Mac first buyer.
Now let's talk about AMD, because this is where the conversation gets interesting in a different way. Ryzen AI Max Plus 395, the Strix Halo family, is appealing for exactly the reasons Apple is appealing. Compact systems. Strong integrated graphics. Efficient design. A more shared memory-flavored philosophy than the old Big Tower plus add-in card story. On paper it looks like the kind of product category that could become the smartest middle ground between Apple elegance and NVIDIA's software gravity.
And the appeal is obvious. If these machines land at attractive prices and the software story keeps improving, they could become very good practical local inference boxes for people who want x86 flexibility without going all the way to a louder, messier GPU tower. That is the bullish AMD case. It is a good case. It is not a fake case.
But it is still not the boring recommendation. And that matters. NVIDIA has the CUDA culture. Apple has the polished appliance culture. AMD still feels more like the enthusiast's clever pick than the safe default for a broad audience. That does not mean it is bad. It means the buyer needs to be a little more comfortable with the idea that they are betting on a category that still feels less settled in mainstream AI walkthroughs.
This is why I think AMD belongs on the watch list more than on the throne. If you enjoy tinkering, if you like smart value plays, if you want x86 flexibility, if you believe the software stack will keep maturing quickly, Strix Halo-class machines are very worth watching. But if you want me to recommend one machine to a Mac-first person who is trying not to make a regrettable purchase, AMD is still harder to place at the top than either Mac Studio or a very intentional NVIDIA choice.
And this is where the final buyer matrix gets simple. If you are a Mac-first generalist and local AI is one serious workload among many, the best answer is usually Mac Studio. If you specifically want the largest in-memory models you can run while staying on Mac OS, the higher memory Studio configuration is the standout answer. If you specifically need CUDA and you know you need CUDA, by NVIDIA on purpose, either DGX Spark for the contained premium route or a tower/workstation path for value.
If you already have two Macs and they are still good enough, waiting is also a valid answer. Not because waiting is glamorous, but because hardware markets move fast and the cheapest upgrade is sometimes the one you do not force early. That is especially true if what you really want is reassurance, not capability. Reassurance is expensive. Real bottlenecks are worth paying to solve.
And the machine I would tell most listeners not to buy is the machine they are choosing mainly to satisfy internet envy. Do not buy DGX Spark because NVIDIA feels prestigious. Do not buy a giant desk-side Blackwell fantasy because the spec sheet sounds like a superhero origin story. Do not wait for M5 forever because the future version always sounds cleaner than the actual product you can use this week. And do not buy an AMD value play unless you are honest that part of the fun is being an enthusiast.
So here is the one-line verdict. If you are already happy on Mac, buy more Mac for convenience, buy NVIDIA only for CUDA, and keep AMD on the watch list. That is the real answer. Not because the other machines are fake. Not because NVIDIA is weak. Not because AMD is irrelevant. But because for a Mac-first buyer, the total experience math is brutal, and the Mac still wins it more often than people on hardware Twitter want to admit.
And if you want the slightly longer version, it goes like this. First choice, wait unless you have a real bottleneck. Second choice if buying now, Mac Studio, with the exact memory tier depending on whether you care more about balance or maximum local model capacity. Third choice, DGX Spark if and only if CUDA compatibility is the purchase reason. Fourth choice, AMD Strix Halo class machines if you are comfortable being early to a promising category. Last place for most listeners, giant desk-side NVIDIA fantasy hardware that solves a different person's problem.
The biggest mistake in local AI buying right now is confusing the most impressive machine with the right machine. The right machine is the one that fits your models, fits your software, and fits your life. And those are not the same thing.
That is why this market is so weird. The loudest products are not always the smartest products. The best software ecosystem is not always the best life fit. The quietest machine is not always the strongest benchmark machine. And the best value machine may still be the wrong machine if it turns the rest of your workflow into friction.
For a Mac-first user in 2026, the center of gravity is still surprisingly stable. Stay on Mac unless you have a specific CUDA reason not to. Treat DGX Spark as a software stack purchase, not a status purchase. Treat DGX Station and Thor-class desk-side hardware as reference objects, not default shopping advice. Treat AMD Strix Halo as promising, not yet boring. And treat M5 rumors as timing context, not purchase logic.
That is the real calm answer in a market full of performative certainty. Buy the machine that makes your actual work better. Not the one that makes the best forum post.
For links and coverage, head to Toby on fitnesstech.com.
I'm Alloy.
I'm Nova.
And this is OpenClaw Daily.
Thanks for listening. We'll be back soon.